Welcome viewers. So in this video lecture, we want to cover some more objective type questions of recurrence relation. So the very first objective type question is this, that suppose that R is a relation on the set of strings of English letters such that we say that two strings they are in a relation if their length of A string is equal to length of B string. Then we want to check that this relation it is reflexive, symmetric or transitive or not. Okay, see, it is very easy question. Suppose that you take one string A, okay, then the length of string A it is equal to the length of string A. Okay, there is no problem in this. Okay, for example, suppose I take one word like Pardeep. Okay, so how many letters do I have in this? I have 7 letters. So length of this string, okay, so, suppose I call it as A, it is equal to 7. Okay, so here you have 7, here you have 7. Okay, so length of string A is equal to length of string A, and it holds true for every string of the given set. Okay, suppose S is the set of string, so it means that A comma A it is the member of the relation. So this relation is reflexive, okay, for all A belonging to S. Now if length of string A equal to length of string B, because in case of symmetric we assume that A comma B they are in a relation. Okay, if length of string A it is equal to length of string B, so you can say here that length of string B it is same as length of string A. Okay, so as length of string B is equal to length of string A, so it means that B comma A it is the member of the relation. Okay, so it is symmetric also. Now number 3, let that A comma B it is in a relation, and B comma C it is in relation. Okay, now as A comma B it is in relation, it means that the length of string A it is equal to length of string B. Okay, similarly length of string B it is equal to length of string C. So ultimately we can say that length of string A this is equal to length of string C. Okay, so it means that A comma C it is the member of the relation. Okay, so you see that this relation it is reflexive. This property gives me reflexive, this property gives me symmetric, this property gives me transitive. Okay, so we can say that this is all of the above. Okay, now the question is this, that which of the following is true. Okay, see, we discussed in our lecture series that greater than or equal to relation, okay, divisibility relation and subset relation, okay, all these are partial order relation. Okay, you can check it in the playlist. Okay, we discussed all the examples, that greater than or equal to relation, divisibility relation and subset relation, all these forms a partial order relation. So in the first option, your greater than or equal to is a partial order relation, it is true. Divisibility, it is also true. Subset, it is also true. So which option is correct? All of the above. Okay, so this option is correct for this problem. Now next question is which of the elements they are comparable. Okay, so I revise you I tell you about the definition of comparable element. If A is in a relation with B, or B is in a relation with A, then we say that elements are comparable. Okay, now here the relationship is the relationship of divisibility. Okay, now check that one element divides the second element or not. Clearly 3 divides 6. Okay, so it means that 3 and 6 they are comparable. Okay, In this option, 5 does not divide 9, 9 does not divide 5. Okay, so they are not comparable. Similarly, 5 does not divide 11, nor 11 divides 5, so they are not comparable. Okay, because divisibility relation does not hold true. Similarly, in this option, 5 does not divide 13, and 13 it does not divide 5. Okay, so these elements they are not comparable. Okay, now in next question we want to tell that which element is the greatest element. Okay, see, greatest element in Z plus is that element, okay, such that every integer divides that integer. Okay, suppose I say that a is the greatest element, it means that every integer divides this integer. Okay, see, actually we cannot find such integers such that every integer divide this greatest element. Okay, mean this element, greatest element. So this is not possible to find. Okay, so we say that no such element exists. Okay, no such element exists. Okay, greatest element in Z plus it does not exist. Okay, now see that what is the lower bound of this set. Okay, uh, in Z plus. Now by lower bound we mean that find that element in Z plus. Okay, uh, greatest lower bound. Okay, we want to find the greatest lower bound. Okay, mean we want to find that element of Z plus. Okay, which divides all these elements. Okay, so in Z plus we have all the positive integers, and the integer which divides all these elements of the set, it is just one only. Okay, it is plus one. Plus one is what that element which divides 1, which divides 2, which divides 4, which divides 5, which divides 10. Okay, so it means that the greatest lower bound of this is 1. Okay, now again the next problem is which of the following elements are comparable. Okay, see clearly 5 divides 15, so first option is correct. Okay, but in second option 5 also divides 20. Okay, this is also correct. 5 divides 25. Okay, so it means that this is also correct. So we can say that all of the above option, this option is correct. Okay, because 5 divides 15, 20 and 25. Okay, now the next problem is maximal elements of coset, an element which is not less than any other element, an element which is not greater than any other element, an element which is not equal to any other element. Okay, or none of the above. Okay, see, an element which is not greater than any other element. Okay, mean in hierarchy it should come at the bottom. Okay, so any element which is not greater than any other element. Okay, this element it is not greater than any other element of this say diagram. Okay, so we can say that this option is the correct answer. Okay, now next, we want to check that which of the following is the transitive relation: A less than or equal to B. See, if I take A less than or equal to B and B less than or equal to C, so ultimately I can say that A is less than or equal to C. So it means that relation is transitive. If I take greater than A greater than B and B greater than C, okay, so it implies A is greater than C. It means that this is also transitive. A equal to B. If I take A equal to B and B equal to C, then I can say that A equal to C. Okay, so it means that it is transitive also. So it means that all of the above this option is correct. Okay, so all these they are transitive relation. All these they are transitive relation. Okay, now here the options in the next question they are incorrect. Uh, question is how many relations are there on a set with n element. Okay, see a number of relations. This formula is 2 raised to the power n square. Okay, 2 raised to the power n square. Okay, number of relations this is equal to 2 raised to the power n square. So there is some typing mistake in this question. Okay, otherwise this B option it is correct. Okay, now next question is that how many reflexive relations are there with a set having n element. Okay, so total number of reflexive relations. Okay, the formula of this is 2 raised to the power n square minus n. Okay, this formula is used for calculating total number of reflexive relation. Likewise, total number of symmetric relation. If they ask, okay, then the formula of this is 2 raised to the power n into n plus 1 divided by 2. Okay. Now, next is which of the following is true? Greater than or equal to is the partial order relation. It is correct. Okay, because I have told you in the previous question also, divisibility is the partial order in Z. Okay, uh, this is correct. It should have been Z plus. Okay, then subset, it is a partial order relation on PS. It is PS. Okay, in PS. Okay, and then all of the above. Okay, see here what I feel is this, that if they are giving this option, so under Z, the subset relation does not hold. Okay, and divisibility relation does not hold in case of Z because 0 does not divide 0. Okay, and the subset relation you cannot define on set Z. Okay, it is always defined on power set. Okay, so as per the rule, this option, A option, is the correct option. Okay, now next question is which of the following is true? Greatest lower bound, it is always is unique if exists. Okay, least upper bound is unique if exist. Okay, maximal elements are unique. See, maximal elements, they are not unique. Okay, only LUB and GLB are unique if they exist. Okay, so it means that both A and B, this option are correct. Okay, whenever greatest lower bound and least upper bound they exist, they are always unique. Okay, so thank you very much viewer for watching this video. More about it will be discussed in the next video lecture.